Today, we live in a global village. A person living in Lahore can communicate with another person living in New York. We hear the buzzwords like telecommunication, LANs, satellites and internet. Data communication and networking is the subject which makes you familiar with the technology surrounding you. In this course, you will search the depths of networking technologies as well as the groundbreaking technologies like LANs and transmission systems. Let's start our journey to explore data communication and networking. Dear students, in this unit, we will introduce you with the fundamental concepts of data communication. Firstly, we will discuss what is a communication model and what are different communication tasks. Then, we will discuss different types of signal and data. We will also study bandwidth and channel capacity of a transmission medium. In the end of this unit, we will study different types of data transmission modes. The objectives of this unit will be to introduce you with the communication model and various communication tasks, to explain you different types of signal and data, to introduce you with the concept of bandwidth and channel capacity of a transmission medium, and to explain you with different types of data transmission modes. Let us start from the communication model. What is a communication model? The model in which a source system communicates with the destination system through a transmission system. A communication model consists of three systems: source system, destination system, and transmission system. Let's proceed to our next objective, that is, the types of signal and data. Let us define data and signal. Let's proceed to our next objective, that is, the types of signal and data. Let us define data and signal. Data is in the form of entities that convey meaning, and signal is an electric or electromagnetic representation of data. There are two types of data. Number one, analog data, and number two, digital data. Analog data is the continuous set of values on some interval. For example, the value which is collected by sensors is in the form of analog data, such as temperature and pressure are continuous valued or analog data. Digital data. Digital data is the discrete set of values. For example, text and images are in the form of digital data. Now we will categorize signals. In a communication system, data are propagated from one point to another point by means of electric signals. There are two types of signals. Number one, analog signal, and number two, digital signal. Analog signal is a continuously varying electromagnetic wave that may be propagated over a variety of media. Digital signal is a sequence of voltage pulses that may be transmitted over a wire medium. Now we will discuss these systems in detail. Let's start from the source system. A source system is a device which generates the data which is to be transmitted. There are many source systems in the real world. For example, a telephone is a source system which generates voice that is to be transmitted to another telephone. A computer is also a source system which generates data which is sent to other computers. The source system sends its data to the destination system with the help of a transmitter. You must be wondering, what is a transmitter? A transmitter is a device which transmits data from source to destination. For example, a modem is a transmitter which takes a stream of data from a source device such as a computer and transmits it to the destination device. In short, the source system consists of a data source followed by the transmitter as shown on the screen. The next system involved in the communication model is the destination system. A destination system is a device which receives the data from the source system. For example, a telephone serves as a destination system and it accepts voice which is transmitted by the source telephone. A computer serves as a destination system and accepts data which is sent by the other computers to it. The destination system receives data from the source system with the help of a receiver. You must be wondering, what is a receiver? A receiver is a device which accepts data from source system on behalf of a destination system. It is situated within a destination system. For example, a modem is a receiver which accepts a stream of data from a source system. The last system of the communication model is the transmission system. This system consists of the transmission medium. Transmission medium is a physical link which is used to transfer the data from source system to destination system. For example, various transmission mediums include cables, wires, fiber optics, and wireless links. Now, let's see what is the purpose of a communication system. The fundamental purpose of a communication system is the exchange of data between two systems. Personal computers and telephones are the examples of communication system. Modes of transmission. The mode of transmission depends upon the type of terminal used in the data communication network and speed at which the data must be transmitted. There are three modes of transmission: simplex transmission, half-duplex transmission, and full duplex transmission. Simplex transmission. In this mode, the data is always transmitted in one direction only. Simplex operation has an advantage that it is very simple to implement. However, its operational capability is limited. Examples of simplex transmission systems are data logging systems, in which a monitoring device returns a reading at regular intervals to the data gathering facility. Receive-only devices such as microcomputer monitors and scanners, and broadcast system and services. Half-duplex transmission. In this mode, data may travel in both directions, but only in one direction at a time. If a station is transmitting data, it cannot receive data from other station at the same time. Some form of protocol is therefore necessary to ensure that one station is in transmitting mode and the other is in receiving mode at one time. Full duplex transmission. In this mode, data may travel simultaneously in stations. This is clearly more costly but is simpler to operate. The examples of such systems are public telephone systems, where
both caller and called person can talk to each other at the same time. You can also find full duplex modems which allow both communicating systems to transfer data to each other simultaneously, as you can see on the screen. This concludes the objectives of this unit. I hope you have fully understood all the topics.